Okay, so if everybody are ready, so let's start with our session untuk pagi ni. So for today's session, we're gonna look into still we are in the chapter 4 hypothesis testing, but right now kita akan lihat untuk a new topic that is one-way ANOVA. Okay, what is one-way ANOVA and what are we going to look into this materials for this part? Okay, so basically when we talk about one-way ANOVA, it's just simply the same as what we did before. So sebelum ni kita dah buat tentang hypothesis testing tentang means. So in this way also, in this topic also, we're going to still look at how we are going to compare the means. Okay, cuma perbezaan dekat sini sekarang ni, kalau untuk yang t-test tu kita hanya gunakan dua saja. So we only have two sample, we only have two groups. So we are comparing means for two groups. So group A and group B, before and after. So there's only two groups. So what happens if we have more than two groups? For example, if we have 3 groups or 4 groups and more. Okay. For this kind of situation, you cannot use the t-test anymore, because the t-test is only applicable for the maximum is 2 groups. Okay, you can have one sample, you can have 2 sample. Okay, that is for t-test. Kalau one sample, that means you are going to compare the mean with a hypothetical values. But for the 2 sample, that means you are comparing between 2 samples means. Okay. So in this situation, if you have more than 2, so what are you going to do? So one of the way is by using one-way ANOVA. Basically, in terms of one-way ANOVA, normally we use ANOVA to compare the variance. Okay, to compare the variance, but it also can be applicable to comparing the means for groups that have 2 or more groups. Okay, for population that have 2 or more groups. Okay, so in this case kita boleh juga gunakan untuk dua, untuk ANOVA kita boleh gunakan untuk 2 sampel. Tapi yang sebenarnya, yang kalau lebih daripada 2, kita tak boleh gunakan t-test, so kita kena gunakan ANOVA. Okay, so basically one-way ANOVA can be used for 2 or more groups of samples. Okay, 2 or more groups. So kita boleh gunakan 2 ataupun lebih. Okay, sebab tu kalau kata kita katakan boleh tak kita gunakan, kalau katakan kita tak nak gunakan t-test untuk 2 sampel, tak compare 2 sampel means, can we use ANOVA? Yes, you can use ANOVA. Okay, sebab ANOVA is applicable for 2 or more samples, not samples, groups. So compare means untuk 2 yang lebih, 2 ke atas. Okay. So the learning objective of this topic will be use the one-way ANOVA techniques to determine if there is a significant difference among 3 or more means. So basically, it's not just 3 or more means, you can also use 2 or more actually. Okay, sebab kalau katakan kita gunakan 2, so kalau katakan we have 2 means and we run the analysis using ANOVA, the result will be the same as the t-test. Okay, kalau kita ada 2 means, kita compare 2 means, tapi instead of using t-test, we use ANOVA, still okay, and the result will be the same as what you have found in t-test. Okay, tetapi kalau katakan dia lebih daripada 2, 3 kan ke atas, that means you cannot use t-test, then you have to use ANOVA. Okay. The F-test used to compare. So sometimes we call this a F-test. So the F-test, because when we talk about ANOVA, we are kalau t-test tu kita compare dengan kita refer to T distribution tables. But for ANOVA, we refer to the F distribution tables. Okay, kita ada F distribution table. So that's why kalau you tengok dekat you all punya statistical tables yang provided to all of you, you akan ada F distribution dengan you akan ada dia punya chi-square distribution. Okay, cuma yang F distribution table tu sometimes it's a bit confusing sikit lah nak baca. So nanti saya akan terangkan lah macam mana nak baca kemudian. Okay, the F test used to compare 2 variances. So normally kita gunakan 2 variances. If you want to kalau katakan compare 2 variances ni, kalau you masih ingat, this is the things when we deal with independent sample t-test. Okay, when we do independent sample t-test, the first thing that we want to look for is to test whether equal variance assumed or unequal variance assumed. So kita nak tengok sama ada variance adakah equal ataupun tidak. So yang tu kita gunakan f-test. So ini yang dinyatakan dalam bila kita compare two variances ni, ini dalam kita buat dalam living test. So the living test is using the f-test because we are comparing two variances. Okay, on top of that, we can also use the f-test to test or compare means between three or more means value from different groups. Okay, so this is what we call as ANOVA. Okay, so kalau katakan kita compare means, three or more means, the technique is called analysis of variance, right? So for three groups, the f-test can only show whether or not the difference exists among the three means, not where the difference lies. So what does it mean? So apa yang dimaksudkan kat sini? So bila dia katakan the f-test can only show whether or not the differences exist among the three means. So maksudnya kat sini adalah the f-test in ANOVA only tells you whether is there exists any difference or not. Okay, ada perbezaan ke tak? Tapi dia tidak menerangkan not where the difference lies. So apa yang dimaksudkan not where the difference lies means that dia tak tengok. Okay, kalau berbeza, yang mana yang berbeza? So dia tak tengok kat situ. Okay, dia tak tunjuk yang tu. So in order to determine which mean differ with the mean yang lain satu. So kalau keadaan 3, adakah mean A dengan mean B differ, ataupun mean A dengan mean C differ, ataupun mean B dengan mean C differ. Which one yang differ? Okay, that one cannot be shown by ANOVA. Okay, untuk tentukan yang mana satu differ, then we have what we call as the post hoc test. Okay, post hoc test is being carried out whenever you see that there exists a difference between the mean in ANOVA. Okay, bila kita dah dapat tahu bahawa terdapatnya perbezaan mean dalam analisis ANOVA kita, barulah kita pergi kepada post hoc test. Kalau, of course, in SPSS, we can run it together. Okay, we can run it together. Tapi, bila kita nak baca output, we always read the ANOVA first. If the ANOVA is significant, showing that there exists difference between the mean, then we go for the result on the post hoc test. Okay, bila kita tengok result pada post hoc test, the post hoc test will compare each pair of the means. So dia akan compare, kalau kita ada 3 means, dia akan compare mean 1 dengan mean 2. Mean 1 dengan mean 3 ada perbezaan ke tak? Mean 2 dengan mean 3 ada perbezaan ke tak? So in that case, we can determine where the difference lies. Kat situ baru kita boleh nampak kat mana dia berbeza. Adakah mean 1 dengan mean 2 berbeza, ataupun mean 1 dengan mean 2 tak beza, tapi mean 2 dengan mean 3 berbeza. So that is the things yang kita boleh lihat. Okay, so that is basically when we talk about ANOVA. So kalau kita kat sini, so ANOVA lebih untuk dia lebih kurang sama macam dalam t-test, di mana kita nak compare means. But in this situation, we are comparing for 3 or more means. Okay. Okay, what is one-way analysis of variance? So analysis of variance, ANOVA tu adalah analysis of variance, and then we have a one-way analysis of variance. We have a two-way analysis of variance and so on. Tapi yang untuk kita, we are only going to look at one-way analysis of variance. It says here, when an f-test is used to test hypotheses concerning the means of 3 or more population, the technique is called analysis of variance, commonly abbreviated as ANOVA. So the one-way analysis of variance test is used to test the equality of 3 or more means using sample variance. Okay, so dia gunakan sample variance untuk menguji adakah terdapatnya perbezaan means. Okay, untuk 3 atau 2 groups. 3 ataupun lebih groups. So 3 or more means using sample variance. So boleh katakan F-test normally they are using the variance to perform the testing. Okay, so these are some of the assumptions for the F-test. The following assumption apply when using the F-test to compare 3 or more means. First, the population from which the samples were obtained must be normally or approximately normally distributed. So this is the must-have assumption because ANOVA is a parametric test. So for all the parametric tests, you must make sure that the population come from a normally distributed population. Okay, the sample come from the normally distributed population. Okay, and then the sample must be independent of each other, meaning to say that sample mean 1, sample mean 2, sample mean 3 are independent of each other. Okay, dia sama macam yang kita buat untuk t-test lah. Kita tahu kalau kita buat independent sample t-test, we must make sure that the samples are independent of each other, right? Male or females, something like that. Okay, and then the variance of the population must be equal. So you must have an equal variance. You cannot have a different variance. Okay, in this situation, to run analysis of variance, one-way analysis of variance, these 3 assumptions must be met in order for the analysis or for the result to be valid. Okay, otherwise, you still have the result, but the result is not valid. Okay, contohnya kalau you run gunakan SPSS, of course, you still can get the output. Okay, without checking on the assumption, you still can get the output. Tapi, whether the output is meaningful or whether the output is valid for generalization or not, depends on the assumption. If the assumption met, then the output obtained is valid. Tapi kalau katakan assumption tak met, that means kita dapat output tapi output tu tak valid. Kita just explain tapi it give you a false information. You will be giving a false information to the audience. Sebab you punya assumption dah tak valid. Dah tak met. So that means you punya result pun tak valid. By right. Okay. So in F-test, 2 different estimate of the population variance are made. So dalam F-test ni kita ada buat 2 estimation. So one is what we call as between group variance, and the second one is the within group variance. Okay, dia ada between group dengan within group. So apa yang maksudkan between group ni? So between group ni maksudnya kita ada 3 group. Contohnya kita gunakan 3 means. So kita ada 3 group, kita ada 3, tiap-tiap group tu ada dia punya data dia. So kita akan compare dia punya variance between group A, group B and group C. So itu yang maksudkan dengan between group. The second estimate within the group variance. So within group maksudnya dalam group A kita boleh kira dia punya variance. Okay, dalam group B kita kira dia punya variance. Okay, so that is what it mean by within group. Nanti kita akan tengok dengan lebih jelas. Okay, in F-test, when to reject or do not reject the hypothesis. So normally, when the F-test value will be close to 1, so you do not reject the null hypothesis. And normally, when the significant value, F-test value will be significantly greater than 1, then you reject the null hypothesis. So this is the same as what we did before. Kita nak reject or do not reject the null hypothesis. So yang ni kita tengoklah. So kalau katakan dia punya variance tu tidak differ antara satu sama lain, because we are comparing the variance in F-test, we are comparing the variance. So if the between group and the within group variance do not differ much, that means they are closely to 1. Sebab kita tengok ratio. Okay. Alhamdulillah. Okay, sorry. So in F-test, we are looking at the ratio between group variance and the within group variance. So bila kita tengok ratio, kalau katakan dia hampir sama, okay, there's not much different. That means the ratio will go definitely will be equal to what? Close to 1. However, if the between group variance will be much larger than within group variance, then it will be larger than 1. Sebab dalam F-test kita tengok dia punya between group variance ratio to the within group variance. So kalau dalam fraction, between tu dekat atas, within tu dekat bawah lah. So kalau yang atas tu lebih tinggi, maknanya nilai dia akan melebihi 1. Tapi kalau katakan dua-dua tu hampir sama, maka dia punya ratio akan jadi almost to 1, close to 1. Okay, so when there is no difference, then that means you do not reject the null hypothesis. Okay, that means in this situation, the null hypothesis will say that there is no difference between the means. Meanwhile, for the alternative hypothesis, it will be at least one pair of mean differ. Okay, sebab kalau katakan kita ada 3 contohnya. Okay, suppose you have 3. So you have group 1, group 2 and group 3. So you can compare 1 and 2. Okay, or you can also compare 1 and 3. Or you can compare 2 and 3. So that means dia ada 3 kat sini kan, comparison. So you have to compare 1 and 2 whether it differ or not, 1 and 3 whether they differ or not, and mean 2 and 3 whether they differ or not. If all the 3 do not differ, then you fail to reject the null hypothesis. However, if one of these differ, contohnya 1 dengan 2 ni, yes, it differ. Yang ni tak differ, yang ni tak differ. Okay? So, at least 1. So that means bila at least 1, then you have to reject the null hypothesis. Okay, maknanya salah satu saja. Cuma dalam ANOVA, kalau kita tengok dalam ANOVA punya output sahaja, dia tak tunjukkanlah yang mana satu yang differ. Dia hanya kata, okay, at least one differ. So, dia terus reject the null hypothesis. So, in order to check which one yang differ, contohnya katakan yang ni 1 dengan 2 ni differ, itu yang kita kena buat post hoc. So, kita kena buat apa yang dipanggil sebagai post hoc test. And then for post hoc test ni, dia ada banyak lah dia punya kaedah. Ada yang menggunakan kaedah Duncan, ada menggunakan kaedah Tukey. Okay, so depends. Nanti kita tengok dalam SPSS, nanti akan tunjuk, nampak lah option dia. Okay. Okay, that is for the some information on the F-test. Okay, let's see one example. Okay, kita ada satu example kat sini. Yang ni example, I think this one is from your McGraw-Hill books. Okay, you boleh tengok example 12.1 kat saya. Boleh cari ya dekat dia. Okay, miles per gallon. So in this case, a researcher wishes to see if there is a difference in the fuel economy for city driving for 3 different type of automobiles. So there are 3 different type of automobiles: small, sedans, and luxury. And he randomly sampled 4 small automobiles, 5 sedans, and 3 luxury automobiles. The miles per gallon for each is shown at so this is the mile per gallon. So yang ni dia punya miles per gallon untuk setiap kategori. So I have 3 category here: small, sedans, and luxury. And they ask you to test at alpha 0.05. Test the claim that there is no difference among the means. So that means all the 3 type of automobile will have the same performance in terms of fuel economy. Okay, the same performance in terms of fuel economy. Okay, so nak tengok adakah betul atau tidak. Tak kira lah you gunakan kereta kecil ke, kereta besar ke, atau kereta luxury ke, dia punya fuel consumption will be at average adalah sama. So, is it true or not? So, kalau kita punya logic, kita katakan, of course, it won't be true, right? So, you know that small car will have a better fuel economy comparing to the larger car, right? Because they have a larger engine. Okay, small car have a smaller engine and the fuel economy will be much better compared to luxury car which have a larger engine. So this is by logic. Okay, selalunya kereta besar-besar ni dia akan makan minyak berbanding dengan kereta kecil. Contohnya macam Beza dengan Perdana. So of course Beza akan lebih jimat minyak berbanding dengan Perdana. Okay, that is the situation, right? So that is by logic. So itu secara logik. So secara statistiknya adakah betul ataupun tidak? So this is what we are going to test. Okay. So how are we going to test this information? So the traditional method. So this is what you have to do previously if you are doing it manually. So ini caranya. So of course if you look through the different textbook, there are different ways of calculating the result. So anyway, whichever method yang you gunakan is still the same. The result will still be the same depending on the situation. Okay, yang mana you nak guna satu. Okay, step 1. So this is common, right? So step 1, we write down the hypothesis. So state the hypothesis and identify the claim. So the hypothesis simply say that mu1 is equal to mu2 is equal to mu3. And this is the claim based on the question. But question tadi katakan is there is no different, right? So ini yang dia question claim. So this will be the claim. Okay. And then H1 at least one mean is different from others. Okay. So at least one mean is different from others. Okay. So that is the hypothesis. Okay. You state the hypothesis. The second step is to find the critical value. So the critical value here, this is from the table. So you can take a table. Okay, you have to look for the table. Okay, in order to look for the table, so in this situation, bila kita nak tengok table, dia ada dua benda kat sini. So dia ada, when we look at the table, so you have to look for F with alpha value. And then you have degrees of freedom 1 and degrees of freedom 2. So ada V1 and V2. So dia ada V1 and V2. Sebab apa? Sebab dalam F-test, so bila kita nak compare F-test, kita compare the value for MSE divided by MSR. Okay. Yang ni dia guna MSB lah kot. So sorry. Sebab kita gunakan ANOVA. So yang ni biasanya untuk this one is actually for regression. So MSE, MSR. Nama pasal aku lah color. Okay, normally this is given by MSB divided by MSW. Okay. So that is why we have 2 degrees of freedom here. One is for the numerator and the other one is for the denominator. Okay, so we have the numerator and denominator, and then we have the alpha values. So in this case, since k is equal to 3 and n is equal to 12. So what is k? What is n? Okay. K here is the number of groups. Tadi kita ada 3 groups. So you have sedan, small, sedan and luxury. So ada 3 group. So k is equal to 3. And then n here is the number of sample overall. So maksudnya tadi kita ada 4 untuk small, 5 untuk sedans and 3 untuk luxury. So campur semua dapat 12. Okay, that is the letter N. So V1 will be the degrees of freedom for the numerator, for the MSB. Yang atas So this is given by k minus 1. So 3 minus 1 is equal to 2. And then n minus k is for the degrees of freedom 2. That is for denominator. So you have n minus k, that is 12 minus 3 equal to 9. So you have the first degree of freedom will be 2, the second degree of freedom will be 9, and your alpha value is equal to 0.05. So when you look at the table here, so you have to look for F 0.05 with 2 degrees of freedom and 9 degrees of freedom. So this will give you 4.26. So you boleh check lah dalam you all punya table F Let's see, kita boleh tengok kat sini ke tak So let me just try to get the table. Science, Math. Saya tunjukkan table tu kat mana tengok 4.26 tu silap tak? Nama saya. Bukan yang ni nak tengok. This one. Sorry. Okay. Let's slow sikit Okay, so this is the table. So kita akan tengok So which one is it? This is table of the Okay, this is chi-square distribution. Oh, dia tak bagi. Ni. Okay, this is the F-test Okay, kalau you perhatikan kat sini, this is the table. So, kalau boleh nampak lah. Hopefully, you boleh refer dekat you all punya table. Saya just terangkan saja Okay, if you look through this one. Okay. Okay, right. Okay. So you have V1 dekat atas ni. So the above part here is V1 and then the second part here on the column is V1 and then the rows will be referring to V2. Okay, the degrees of freedom for the second one. And then for each of the cells, the cross here, the cross cell over here. So let's say 1 and 1 here, dia ada 4 nilai dekat situ. Okay, ada 4 nilai dekat situ. So in order to look for which value yang you perlu refer, you kena tengok dekat the description Okay, here it says here F alpha V1 V2 is tabulated for alpha equal to 0.05, 0.025, 0.01 and 0.001. The 0.025 value being bracket. So that means baris yang pertama dalam ni So baris yang pertama adalah untuk alpha 0.05. The second one that is in bracket, this is for 0.025 and then you have 0.01 and 0.001 the star. So that means if your alpha is 0.05, you look for the first row for each of these So for example just now kita punya first degree of freedom is 2. So, you tengok dekat kolom yang kedua. And then, our second degrees of freedom is 12. So, you look until 12 over here. Okay. 12 Sorry. 9 9. Okay, 2 and 9 So, 9. So tengok baris yang kolom yang kedua and then tengok baris yang ke-9, ada nombor 9 kat sini. And then look for the first row because the first row representing alpha equal to 0.05. So here you see that the value is 4.26. So itu yang kita dapat kat sini, 4.26. Okay. So that is how you look for the critical values from the F distribution table. Okay, once you have the critical value, the next thing is to do is to compute the test statistic. That is F value statistic. Okay, tadi kita dapat F value from the table, right? So right now, we have to calculate the F value statistic. So yang ni lah. So you have to calculate this part. Okay, in order to calculate this part, you need the value for the MSB and MSW. So how to calculate this value from a raw score, from a raw values? Okay. Okay, the first thing that you need to do is to calculate the grand mean. Okay, to calculate the grand mean. So grand mean maksudnya kita dapatkan the mean overall. Okay, we calculate the grand mean, the mean overall. So you calculate the grand mean 36 plus 44 and so on divided by 12. So campurkan semua nilai and then bagikan dengan 12, you akan dapat the grand mean equal to 33.667. Okay. Okay, this is one of the way to calculate it. Of course, there are other ways to calculate the F test value. And then compute the test value. Okay, this is continue from the previous one. So you have to calculate the between group and the within group. So macam mana nak calculate the between group and the within group? Okay, yang ni depan ni ada formula sikit. So this one supposed to be NI. So sorry. So dia ada NI dekat sini. Okay, NI X bar I, X bar GM. So apa maksud dekat sini? So apa maksud NI multiply with X bar I minus X bar GM square. Okay, ni apa dia? So this one is actually, this part is actually mean for each group. Okay, so that means you have to calculate the mean for each group. So kalau compare dekat sini, kita ada data yang ni. So that means to calculate mean for each of the small, sedans and luxury groups. So which means that you have to calculate the mean for small, sedans and luxury. Okay, that is one way. Okay, satu cara adalah kita dapatkan dia punya mean gunakan dengan compare dengan dia punya grand mean. So what you need to do is just simply for small, sum all this value divided by 4. For sedan, sum all the values in sedan and then divided by 5. And for luxury, sum all the value for the luxury car, mileage, and then divided by 4. Okay? Divided by 3. So you have the mean for each of the groups. Okay, so that is what you have over here. Okay, so you have over here. So you have this value. So you need to get the mean. So 37.25 minus 33.667. So this is the mean for the first group. And then NI is 4. So group 1 ada 4 data. So 4 kali dengan this one lah. Alright, and then continue with the second one and the third one. And then divide by 3k minus 1, that is 3 minus 1, so you get the value for this one. Okay. So this is actually the MSB. So nanti jangan confuse, dia ada sum of square dengan mean square. So this part, sum of square is 242.717 and then mean square is simply 242.717 divided by 2. Ni kalau tengok dalam table nanti So you kena betul-betul hati-hati So kita ada dalam table nanti kita akan tengok dia ada sum of square dengan mean square. So mean square yang kita bahagikan dengan dia punya degrees of freedom. Okay, sum of square divided by degrees of freedom will give you the mean square. So in this case, this is simply equal to the sum of square between divided by this one is k minus 1. Okay, for this one it will be MSW. So this is just simply sum of square W divided by n minus k. Okay, so the degrees of freedom. So this is for the between group. So between group, you ambil dia punya nilai mean bagi setiap group, tolakkan dengan grand mean, kuasa 2 kan, and then darabkan dengan dia punya bilangan data. And you do this for all the 3 groups, and then sum them all together. Then you get the sum of square between. And then you divide by the degrees of freedom, so you get the mean square of the between. Okay. For within group variance, what you can do is just simply using this formula, that is summation of ni minus 1 times si squared. So what is this si squared? So this is the standard deviation or the variance. So kalau si squared ni is the variance. So the variance for each of the group. Okay, you kena kirakan variance for each of the groups. So, kena kira lah variance. So, macam mana nak kira variance? So, refer balik kaedah untuk kira variance dalam tajuk yang sebelum ni. So, macam mana kita nak kira variance untuk satu group? So, kita ada formula mean summation of x. Okay, we have the mean can be found by using summation of x divided by n, right? And then for the standard version, or the s squared is just simply equal to 1 over n minus 1 multiplied with summation of x squared minus summation of x squared divided by n, right? So you have to use this formula to get the si squared. So using the si squared, so you calculate, you get the ssw divided by the degrees of freedom, you get the msw. Okay, so once you have calculated this value manually, the next thing is to calculate the F test. So this is the last step. So dalam calculating the F statistic, dia ada 3 step dekat sini. Kalau tengok yang ni, untuk yang kaedah ni, ada 3 step. So the first step is to calculate the grand mean. The second step is to calculate the between group and within group variance. And the third step is to calculate the F value or F statistic value. So this is given by the ratio mean square between divided by the mean square within. So in this case, you get the value to be 4.83. Okay, you dapat 4.83. Again, step yang keempat to make your decision. So your decision, if the value for the F value exceed the critical value, then you reject the null hypothesis. Okay, so in this situation, your 4.83 is greater than 4.26. So this is F stat, and then this one is F critical value, right? So if the F stat is greater than the critical value F, then you reject the null hypothesis. So in this case, your result is reject H naught. So when you reject H naught, you conclude H1, saying that at least one of the mean differ. So in this case, to summarize the result, you say that there is enough evidence to reject the claim and conclude that at least one mean is different from the others. Okay, itu saja yang diterangkan oleh ANOVA. Which mean differ cannot be given by the ANOVA result. Okay, kalau kata nak tengok yang mana satu yang differ, sebab yang ni dia just bagi tahu salah satu berbeza. Yang mana satu yang berbeza, kita tak boleh tahu daripada sini. So you have to run the post hoc test. Okay, you have to run the post hoc test in order to determine which mean value differ. Okay, tapi yang tu tidak ada dalam kita punya syllabus. We are not going to discuss that, right? Tapi kalau you nak gunakan dalam your punya report nanti, boleh. For those yang buat ANOVA untuk you punya analysis, you can include that as an extra information to determine which one differ. Sebab yang tu kita boleh dapatkan daripada output. Nanti saya akan tunjukkan macam mana. Okay? Any questions so far? Tak ada, eh? Okay. Alright, so ANOVA, the between group variant is sometimes called the mean square. Okay, tadi saya sebut kan, so the mean square. The between group variant is the mean square, MSB. And the numerator of the formula for the MSB sometimes also called as the sum of square between SSB. Itu yang saya tunjuk tadi, eh. So just now I've already shown you that MSB can be written as the sum of square between divided by the degrees of freedom, right? So in this case, the degrees of freedom is K minus 1. MSW can also be written as SSW divided by degrees of freedom 2. That is N minus K. So in this case, dF1 is simply equal to K minus 1 and dF2 is simply equal to N minus K, where K equal to number of groups. Okay, clear? So that is in general ANOVA tu, dia punya table ANOVA tu, nanti kita tengok lah. So basically all this information can be shown in a table form. Okay, normally when you run the analysis using SPSS or any other statistical software, they will give you the output in the form of tables of ANOVA. Okay, so the ANOVA table will be something looking like this. Okay, so ANOVA table, you have between and within. The same table also display in regression analysis later on. If you look through when we discuss on regression analysis, it will also give you the same type of table for the ANOVA untuk regression analysis. Cuma dia punya source tu will be different. So in the source for regression analysis, they will give you the error and the regression. Okay, tapi untuk ANOVA, untuk yang compare means ni, they give you between and within. Okay, so this is how you read the table. So you have the analysis of variance table. So you have between, sum of square, and then you have the degrees of freedom, mean square, and then the F test. Okay, so in this case, the F here is just simply equal to MSB divided by MSW. Okay, MSB divided by MSW. So for the previous example, you found that the sum of square is 2 for between 242.717 and the degrees of freedom is 2, and you take the ratio between the sum of square with the degrees of freedom, then you get the mean square. Similarly, for the within the error, you find the sum of square and then divide with the degrees of freedom, you get the mean square. Okay, so in this case, the total is just simply the sum of these two. So the degrees of freedom here is sum of these two. 2 plus 9, you get 11. So basically, this one is K minus 1. So this is N minus K. So this is basically N minus 1. Okay. Right. So that is the situation. Alright. So this is the ANOVA table. and how you can read the table. Okay, macam mana dapatkan nilai-nilai tadi Okay. So this is the output given in the SPSS. So sama saja dia bagi macam ni kan. Okay, ni output yang kita dapatkan dari SPSS. So cuma dekat sini untuk SPSS dia akan ada satu bahagian kat sini significant. Okay, remember last time when we deal with hypothesis testing for difference between two means, you have three methods in order to determine whether is there any difference or not. One is using the traditional method, that is using the critical value macam kita buat tadi. The second one is using the p-value. Okay, the same thing applies here. For ANOVA also you can use the p-value, so you compare the p-value with the alpha value. If significant value here is greater than alpha, so in this case you fail to reject. Okay, then if your significant value is less than alpha, then your result will be reject H0. So in our case right now is 0.38, which is less than 0.05. So you reject the null hypothesis. So this is based on the significant value. So based on the above table using p-value methods, again the hypothesis will be H0 mu1 equal to mu2 equal to mu3, and H1 at least one mean is different from the others. So since p-value here is less than 0.05, so you reject the null hypothesis. That means at least one mean is different from others. Okay. Okay, you can try this yourself. Okay, kita boleh tengok kat sini. You boleh cuba dapatkan dia punya jawapan. Kat sini you ada condiments, cereals and dessert. And try to calculate this manually and see whether you get the same answer or not. Okay. And you can also try using the SPSS for the same information and look for whether you get the same result as this one or not. Okay, kat sini saya dah bagikan dia punya procedure untuk SPSS yang mana you boleh tengok lah. So yang ni contoh untuk yang one way ANOVA ni. Okay, you boleh try this one first using your SPSS. So the club 1, club 2 dengan club 3 you ada values there. So this is another way of calculating the ANOVA. So you have the mean and then the variance and also the the mean for each group and the grand mean. Okay, so and then you calculate the SSA. So this one is SSA dengan SSW. So samalah SSB dengan SSW. Okay. Cuma kat sini dia gunakan kaedah yang berbeza sedikit. Okay, dia gunakan kaedah yang berbeza sedikit. Sama sama kaedah yang sama So dia gunakan kaedah yang sama yang saya tunjukkan tadi. And then dia dapatlah dia punya nilai. And then you boleh baca terus. And you can try this data with the SPSS. So kat sini saya dah bagikan dia punya kaedah macam mana you nak tentukan nak gunakan SPSS untuk you run the analysis. Okay, for example, in this case, step 1, enter data into SPSS. So this is how you enter your data. So you have the first column, all the values. And then the second column give you the categories. So you kena nyatakanlah categories. So in this case, kita kena gunakan nilai lah mudah So kita gunakan 1, 2, 3. So you have the first one is group 1. The first 5 is group 1, club 1. The second, the next 5 will be club 2, and then the next one will be club 3. So dia hanya ada 2 kolom saja. Satu kolom adalah untuk dia punya value, satu lagi kolom untuk dia punya category. And then you go for analyze, choose compare means, and then take one way ANOVA. Okay, so the step 4, once you dah masukkan dah dapat dia punya box, dialog box, so you transfer the values into the dependent list and then you punya grouping tadi dalam factors, and then click the significant level. Okay, you click on the contrast. Okay, click on the multiple correlation, post hoc tu boleh pun. Okay, you click on the one-way ANOVA post hoc multiple comparison. You choose the significant level to be equal to 0.05. Okay, make sure that is equal to 0.05. And if you see here under the first part there is equal variance assumed. So here you have the test, what we call as a post hoc test, in order to determine if which mean differ. Dia ada selection kat situ lah yang you all boleh buat. Either you want to use LSD or you can use Bonferroni untuk check which means differ, ataupun Tukey ataupun Duncan. So semuanya boleh gunakan. So you have to use, you can compare using these techniques. So boleh pilih mana-mana satu lah. So yang biasa digunakan adalah Tukey, LSD, Bonferroni dengan Duncan. Itu yang kebiasaannya digunakan. Okay. And then you ada equal variance not assumed. Kalau katakan you not assume equal variance, so these are some of the techniques that you can use for the post hoc test. Alright. Okay, and then for the one-way ANOVA option, make sure you choose the descriptive to give you the descriptive information that give you the mean and also the standard deviation for each of the groups. And then yang lain tu biarkanlah, and then click continue and then click OK to run the analysis. Okay, once you dah OK, you get this information. Okay, this is the output. So you ada the first part is the descriptive. Okay, the first part is the descriptive. So you have the descriptive information. Okay, sample mean, sample standard deviation, and so on. So you can see that there is a you have the mean and also the standard deviation for each of the groups, and also for the grand mean and the grand standard deviation. Okay, this is given by the descriptive table. And then the second table that I can see is the ANOVA table. So kat situ saya dah tunjukkan. Okay, nombor satu tu apa dia? So nombor satu sample means and standard deviation. Nombor dua adalah grand mean and standard deviation. Number 3 will be the calculated F statistic value, and then number 4 will be the significant values or the p value. And inside the cell you have the sum of square between groups and within group, and also the degrees of freedom, and also the mean square. Okay. Alright, so that is all for ANOVA. Any questions?